So who's ready for a field trip? Yay! All right. It's always a good day for field trips.
I'm wearing my mask just because I was trying to keep...
We had a greeting committee. She's,
Mr. Rasmussen,
Thank you.
he's the other science teacher at Winter Lakes. So I'll have everybody get off the bus. And
oh yeah, you know I got to get a little. Here we are, getting out, getting on the go. This is a great and wonderful group we got. Woohoo! And new building here, Umpqua Hall, and that's the one we're getting to go into. Thank you, thank you, thank you. Beautiful.
So be camera ready if you'd like. Say cheese. You look like you're having fun, learning some sciencey things.
Dr. Pointer, and he's out here.
Where's the closest restroom?
Just right down around to your right.
Okay.
Around to the right,
Anybody needs to use the bathroom, just go back.
and we're going right in here
And you
in the
guys can just
physics.
come right in.
All right, who's the first?
I'll go in.
There you go.
Look around the lab.
As soon as it gets started, they'll all go.
And actually keep track of atmospheric data when we do that, while simultaneously annoying most of the flight control people at the tower. But we
How bad?
only because they make it.
Ooh, look at all that
We
stuff.
have been working on a number of projects. A lot of them are to look for and analyze meteorites in the area and look for near-Earth asteroids using software, and the students will explain that a little bit as we go. Toward the middle of you guys' visit, I'm actually going to have one of my colleagues here at Swooc, Dan Neal, who does a lot of observational astronomy and sort of continuing education on sky observing, will join us to talk about telescopes in general and talk about acclimating to the night sky. And then if we get bored, I suppose we can have CJ launch things off with the trebuchet that he built for my class last week. So things of that nature. We're glad to have you. This is part of our Prisms program and part of our Prisms outreach, and I will defer to Crystal for a little bit, because she can tell you a little bit about what the outreach component of Prisms is and
Prisms Project Coordinator, which is a program that is ran through the OSGC, which is Oregon NASA Space Grant Consortium. And this neat project allows us to be able to continue to support our student researchers and their various research projects that they're going to tell you a little bit about. Also, another fun part is how I got to meet all of you is our K-12 outreach to reach out to the various teachers in the area and see how we can support your teachers and your STEM education. And that's what got you guys here. So we're really excited that you guys were able to come see it. So I'm going to now pass it on to one of the students here to have them introduce themselves and let you know kind of what they're working on.
I'm a student here at Swooc, obviously, and I guess I can talk to you a little bit about Project Starfall, one of our projects as the SPEAR research team.
For now, just tell them about your academic plan and stuff.
Future academic plans are cool. I'll start with that. So I'm actually majoring as a physics student here, so I'll be getting my associates in physics by spring this year, or next year, whatever. And then I'll be transferring over to University of Oregon, where I can pursue a bachelor's in like theoretical physics and astrophysics, and we'll kind of see where things go from there. But kind of seeing myself working, like doing some theoretical physics and stuff like that would be really interesting.
And I'm CJ, student here as well. I am working towards a physics degree, and hopefully, we'll be transferred to OSU for astronomy.
I'm Cameron. I'm here. Not going to get a degree, but I'm getting credit so I can go to OSU, and I'm going to study nuclear engineering there.
Well, you will probably get a degree because you'll have enough credits for these just general associated science stuff.
They'll give me a piece of paper. All right.
Yeah.
You will get one for here too because you'll have enough credits for it.
I get another piece of paper.
Yeah.
That's awesome. All right.
And then he's looking at nuclear engineering. We have a few more of our students that'll filter in. Some of them are mechanical engineering students. Some of them are. We've actually done a lot of work with our chemistry department as well. So we have chemistry majors that come in through here.
Astronomical search collaboration, where we look at pictures from a telescope in Hawaii to find near-Earth asteroids. And so we use a program called Astrometrica that stacks the images that we receive, and they basically will flash, so they'll just present one image after the next. And you're looking for, that's exactly it. So you're looking for a moving object up there, and the red one is a known object. So basically all the stars are going to be stationary since they're so far away. The closer objects, which are the asteroids, will be moving along.
Do you want your visual? Do you want the
Starfall Project.
Sure, I can.
Jake is
Yours definitely more visuals. I just needed the one.
And they're videoing it for our YouTube channel, so you might want to stand in front so Mr. Rasmussen's not going back and forth. There
good
we go.
thinking.
So now we have Winter Lakes folks that are online. We have hundreds of online students. They view our YouTube video, so you'll be sponsored on there.
Alright, so our Starfall project is basically just a project where we are looking for fragments of larger meteorites or cosmic dust that has actually landed here on Earth. And there's like a simple process that we can actually do to kind of find out if there are actually any candidates there. So the first process is actually trying to go and collect like samples of this stuff. So most commonly what we do is we have like a collection bag where we use magnets in storm drains. And so basically when there's like rainfall, which there's a lot of here in Oregon on the coast, that debris will be washed from the roof down the storm drain, and any micrometeorite samples will actually be magnetized to that magnet along with a lot of debris. So that's when our next step comes in, where we actually go to clean the sample, where we're just basically washing it away, all the dirt and stuff, so we're just left with those micrometeorite samples. And once we do that, we kind of sift through all the stuff, and so that's like, we kind of know some specification for what the actual micrometeorites are going to be. Then we can actually put those samples underneath a microscope, and there's certain like qualifications that we need to look for when we're looking for a micrometeorite. So we kind of look and analyze, see if we can find any of the actual samples, and if we do find some actual samples, which I believe we have some, I'm not sure if we have any pictures.
Yeah, we do.
Samples, but we actually get to collect those and kind of set them off aside and send them to a place like OSU or PSU, where they can for sure identify if they are actual micrometeorite samples. And
So this is one of our samples from last collection cycle, and this was taken by one of our students, Ellie Jones, who's now a horticulture major at Oregon State. She graduated from Swooc in June and started classes at OSU in September. This is actually one of our micrometeorite candidates, and just for comparison's sake, this is actually the hair of an eyelash. That's the longer strand compared to the size of essential micrometeorite we're looking for. This is why we're using the microscope to find it, is because we're looking at typically very rounded objects that are less than 250 microns across, that are metallic but rocky in nature. So we have various literature and various books that we're able to use to compare and contrast. And I forget the number. I know we've talked about it, but what is it like? Is it 1 micrometeorite per square meter on the planet every year?
every year, yeah.
So a lot of the places we can look are places with really flat roofs, or places that get a lot of rain that get basically sediment that washes down in downspouts and guttering systems, and we can actually place a magnet in the downspouts or in the gutters, and as the sediment is being washed down by a heavy rainstorm, the magnet will pull out any of the sediment that has any magnetic properties, and we expect that most of these micrometeorites would have magnetic properties because there would be a high amount of iron and nickel involved. And, yeah.
I'm Damien. I am an engineering student here at Swooc. Right now I am planning to transfer to Oregon State next year for mechanical and civil engineering, but I'm focusing more in the aerospace area now. And Zach and I had just finished a program known as, did you talk about NCAS?
I haven't talked about NCAS yet, so that was the gist.
All right, yeah. So
you
basically,
don't have to talk necessarily about Mango, but you can at least talk
Yeah.
about it.
NCAS was a really cool program that if you are interested in STEM at all, I would highly recommend. It was a chance for us to join about 900 other people across the country as we competed to put together, actually Jake did this too. We competed to put together a whole mission to Mars, pretty much. We covered everything from the initial design, our launch dates, everything that from start to, it was all theoretical, you know, it was just a PowerPoint, but we put our heads together with a bunch of people across the country and we competed, and Jake and I both won. Yeah.
Cool.
Balloons. We've got kind of in this cabinet here these bags that you see, balloons. We fill them up with helium, and we will actually attach a kind of like a fishing line to them and attach there's an instrument called a radiosonde that will capture data as it goes up in the air, that will capture a bunch of information, and it will send it down to our ground station where we're at, where we started, on the computer, and then we'll be able to take all that information and analyze it later. We actually have had we've had some that have got way up there. What was our top one was?
I think 95,000 feet.
About 95,000 feet.
As high as the last one got.
And so it went way up, and we actually get to watch it on the computer, kind of where it goes, the GPS, and it's really neat. And so if you're interested,
I brought along my friend Dan Neal, who's had some experience here at SWOC as both an astronomy instructor and a track coach, and he's done a lot of community education on observing the night sky, getting acclimated to the night sky, and then just some general training on telescopes, because you have had some experience with building and maintaining them. So, and I thought for the telescope component of this, even though it doesn't look like the weather's going to cooperate for actual telescope viewing, we could at least get to learn a little bit about telescopes and acclimating to the night sky. And I'll turn it over to Dan for a little while.
How you guys doing?
Good.
Did all that? I didn't do well in science in high school or college. What happened to me is I used to own a gymnastics school down in Coos Bay. And I rode my bike there all the time. Rode my bike to there and back. I lived up by Triple Day, so like going to work was easy. It was a downhill for 1 mile. You know, I just had to run a couple stop signs and I was there right at the gym without pedaling. But one night I was riding home and got up on Ocean before they put the lights up there, and the sky was like jet black. And I looked up and I saw this, I thought it was a cloud, you know, and I looked and I go, wow, that's a weird cloud. I wonder what kind of cloud that is. And as I looked at that, it dawned on me it wasn't a cloud, it was like the Milky Way. I didn't know what the Milky Way was then. Anyway, all I know is it was like phenomenal. And at that time I was teaching weight training here, and I was teaching physical conditioning. And so I lucked out, karma. I went into my weight training class and I said, did anybody see the sky last night? It was like incredible. And there was this really old guy there, I think he was about 60. Of course I'm 70 now. But at that time he seemed like a really old dude. And the guy said, yeah, wasn't it great? He said, my daughter and I were out looking at the Andromeda Galaxy. And I said, you're looking at the what? The Andromeda Galaxy. And I go, what's a galaxy? Well, you go, you know, it's like the Milky Way. What's the Milky Way? I don't know what that is either. educate me. And he goes,
And then in the corner, there's also a hydraulic pump that a group of my students made.
Geology section.
They had taken medical tubing.
Woohoo! Okay, you got me?
I got you, Bruce. Yes, you got it. Woo!
So they could get out of the distance of arrows and launch this heavy projectile and knock down the castle walls and then storm it. That's where these came about.
Actually, I was.
Nice. Nice. Pulls it down and lets it go. Yes, that'll make it all the way down the hall. Down, yeah, no, baby. There it goes. Yeah.
Go ahead.
Okay.
Well, we're all getting into it now. Cool. Did you have a good time?
Absolutely. It was very interesting to listen to all the new physics and metric programs that they have at Swooc.
And you know what? I think I might just say it and not say it to them in there. I was going to tell them in there. But I thought they represented very well for Winter Lakes.
Absolutely.
Even
Absolutely.
through the slightly lengthy telescope lecture.
Yes.
But,
yes.
but did really well.
Absolutely.
Oh, and here they are. Did you have a good time?
yeah.
Did you have a good time? Yes? Did you have a good time? Give me a yeah. All right, and the best time is coming. Did you have a good time? Austin, did you have a good time?
No.
All right. All right. Okay, so